Hey, this one is for GCSE biologists, whether you're doing combined science or separate science. This is the sampling practical. I've got an example question to do with you to help you if you have to plan this kind of practical. Describe a method to investigate if light intensity affects the number of buttercups in a field. Now, if we want an estimate for the number of buttercups, we're obviously going to use a quadrat and we're going to be counting buttercups. We have to sample using a quadrat because we can't count every single buttercup. That would be crazy, far too time consuming. There's different ways to do this though, right? If you've got a field, it might be that like half of the field is shaded and half of the field is brightly lit, much more sunny. Now, if you're thinking of it that way, what you could do is use a transect. Now, a transect is basically a tape measure that you could put across the field from the shaded area into the light area, and then you could lay your quadrat at regular intervals along the transect. That's what we call systematic sampling. You've got a system to it. It's not random. So you could have gone down that route. So let's put together an answer. So you could say lay a transect from a shaded area into a well-lit area, because you might have this kind of light intensity gradient. Then you're going to place your quadrat at regular intervals, or I don't know, every 2 meters along the transect. And each time you place the quadrat, you're going to count the number of buttercups. And you could also say use a light meter to measure the light intensity. Now, thinking about repeats are always important, right? You're probably not just going to do one transect. You're probably going to do repeats of that transect parallel to your original transect, again going from shaded into light. And you're not just going to place your quadrat once on the transect. You're obviously going to place it at regular intervals so that you've got repeated quadrats along each transect. So use a large number of quadrats and repeat the transect. So you've got many quadrats on each transect and you've repeated the transects as well. So you've got lots of data. And then finally, you could compare light intensity, because remember, you've measured it using a light meter in every single quadrat. So compare light intensity to number of buttercups. You could plot like a scatter graph, right, to see if there is a positive correlation, a negative correlation, or no correlation. Now, this would be one example, because you're assuming that you've got this gradient, that you can use a transect, regular interval quadrats to go from shaded to light. That would be one idea, but you could go down the random sampling route, and that would be absolutely fine. You might be assuming that there's no clear kind of brightly lit area and no kind of clearly defined shaded area. Now, if that's the case, you would still do a very similar experiment, but you wouldn't be using a transect. So imagine this is your field, and you're going to do random sampling. Now, when you want to do random sampling, you want to lay tape measures at right angles of the field, because this is going to help you figure out where to position your quadrats. So you'd have like a tape measure here, and you'd have a tape measure here. And then, this is random sampling, use a random number generator to get your coordinates. And this is where the tape measures are needed. Say you generate a 1 and a 5 with your random number generator. You'd go to 1 meter on this tape measure, you'd go to 5 meters on this tape measure, and that is telling you where to place your first quadrat. So we've used our random number generator, which is really important. Random sampling, random to avoid bias. You're going to use many quadrats. With this kind of method, you want at least 10, maybe even more than 10. Random number generator, use many quadrats. Again, you're still going to have to say count the number of buttercups in each quadrat. And you're still going to have to say measure the light intensity in each quadrat with a light meter. And the rest of your answer would be the same. Once you've done many repeated quadrats, you've got a large sample. Here they've been placed at random, so it's not biased. You've measured the light intensity in each quadrat with a light meter. You could plot a scatter graph of light intensity against number of buttercups to see if there's a positive correlation, a negative correlation, or no correlation. Key things to remember with sampling, right? Repeats, large number of quadrats. If it's just the population size in a field, you're probably going to go for random sampling. If you're thinking about seeing how the distribution changes across a gradient, like from shade to light, you're probably going to use a transect with your quadrats. I mean, there's so many options for this. They even allowed students to say, well, choose 2 fields. Even though it says a field, students still got credit if they said, well, choose a field that is bright and choose a field that is shaded. Do random sampling in both with a large number of quadrats, count the number of buttercups, work out the mean number of buttercups per field, and compare those results to see which field has the most. Okay? Very similar answers, lots of different ways to do it, but hopefully this video has helped you to improve your knowledge of sampling techniques. Remember, this is a required practical, very, very likely to come up on paper 2.